All right. Hey everyone, I'm David Room. Tonight we're going to be doing some more game development. Um, I am kind of working on an effort, and I think you might have seen a little bit of this last time to sort of clean up a few things that maybe used to not be working quite correctly in my game, things that were sort of maybe on the backlog, and sort of polishing some things um, specifically ship systems and things like that. So, and also the physics. So I think last time I was working a little bit on cleaning up some miscellaneous physics related things, and so we're doing something similar here today. We're going to um, work on, first of all, a couple of gauges in the UI for drive and thruster acceleration. I'm not sure if that's exactly the right way to show things, but um, this is kind of towards being a little bit more accurate or precise with how I'm modeling how the drives and thrusters in the ship work, how they're related, things like eventually getting into things like heat and energy usage, which we might get into today. For those systems, we'll see. But for starters, I'm just trying to build some UI elements so we can visualize this stuff easier. And the end goal is to just have these systems kind of be modeled a little bit more realistically and put some polish on it. So let's get right into it. I'm going to turn on some white bat audio as usual. And let's see, I'm listening again. I'm going to listen again to this Cyberpunk Dark Synth mix Plasma of his. I really was enjoying that last time, so we're going to get into it again here. And let me just share on X to make sure that that the link is there for anybody who is coming from X. And let's just get into it. So, close out some of this stuff and reopen what we're actually going to be working with here. So, for a long time, we've just had one gauge here, and actually I'm just going to disable the mouse quick. And Karayu in the comment says, "Hi, how's it going?" Okay, so for a long time we've just had one gauge for sort of the main, well, we've had one gauge for acceleration, and this kind of showed both acceleration from the main drives and the thrusters, and now we want to get more principled about separating those. So I've created two more gauges here. Last time I was just kind of working on where they are. We also have to put them in the right spot for the interior view, but I'm probably not going to worry about that today. They'll just be they'll be where they landed now. We'll focus on the external view. But my intention is to show the acceleration from the main drives, the acceleration from the linear acceleration from the thrusters, and then the acceleration from, or the angular acceleration from the thrusters. So Inkarayu says, I started Python 2 days ago. How long will it take to be like you? Well, I've been programming in Python, I think, since 2014, so about 12 years. Um, but it's never too late to learn anything, and there's so many good resources now for learning Python programming. I'm sure you'll be all caught up very soon. Okay, so uh, the first thing that we're going to do here is we have this module and class for a HUD, and that kind of has all of these elements in it. And something that I've started doing is separating some of these things into more like distinct objects, and specifically kind of record types that just hold fields rather than having methods. And one of the things that I've been kind of coming to realize with this project as I get into it deeper is there's so much initialization logic to everything, is that you end up with these giant classes that have, I avoid using methods, but I have these giant classes that have a ton of initialization logic, and it's just completely out of hand. So what we're gonna try to do here is separate some of these gauges that are related to things like velocity and acceleration into their own objects. So Robo Sword Codes says, "Hey bro," in the chat, and he asks, "What are you using for the game dev?" So I'm using Python. The IDE I'm using is PyCharm. You can use whatever IDE you want, and I'm using an older game engine called Panda 3D, and it's kind of obscure, but it's actually an engine that Disney developed. I think actually about 20 years ago. They had some MMOs that they developed Panda 3D for, and I'm using Panda 3D because in my day job I work with computer vision, machine learning, kind of data sciencey type stuff. So Python is sort of my bread and butter. I really like Python, and it's an engine that uses Python and is pretty well documented. So that's what I've been using. Yep, Panda 3D. It definitely has some quirks, and it's definitely older, but it kind of works for the style of game that I'm making because I'm not trying to make a game necessarily with modern rendering. It has kind of a retro style. So okay, so Robo Sword Code says, "All right, I actually do Pygame." Yeah, I've heard of that as well. And Enkarayu says, "How long will it take you for you to make this game?" So this is just a little hobby project. I've been working on it for a few years, and it'll probably take a few years more to get it to where I'd release it. But it's a fun project, and there's a lot of different aspects to it that I enjoy, and little rabbit trails that I go down. So finishing isn't necessarily the goal. So, are you asking? So, RoboSword Cards, can you run this, please? Are you asking for me to run the game? So, I'll just show you a little bit of space flight. It's modeled kind of style-wise after some older flight sims from the 1990s that I really liked. TIE Fighter and Descent Free Space and Mech Warrior 2. With sort of vintage style graphics, but it has much more realistic physics than those games. So it's got the Newtonian physics where you can drift and spin and stuff. And the idea is that it will have very fast-paced and very kind of weird combat. And I'm not sure exactly what the gameplay will be like. I'm kind of focused on having it be realistic first, and then we'll figure out how to make it into a good game later, but this is what it looks like. And just an example of some more maybe more like fast-paced combat. So here we have this large ship that's being attacked by a bunch of smaller ships. They're moving around, and it's firing turrets at them. So if you've seen things like The Expanse, uh, that kind of combat is something that I'm kind of shooting for here. And I'm also uh, part of the goal here is to sort of be able to make cool space combat scenes and just figure out what space, like realistic space combat would look like. Realistic just being realistic physics and kind of the rules of my sci-fi setting that I have. So uh, there's a bit of an emphasis on just like making cool looking stuff here. Um, so So Codes asks, how did you do that in Python? Well, you'll see as I do some programming today, there's a lot of separate components and systems. Oh, he's spinning out of control there. But the key is sort of breaking the problem down into small pieces and building one piece at a time and seeing where it goes. So right now I'm working on the physics. I've got some issues with things being a little bit too spinny, but these are all things that you can tweak, and that's part of a project, is like just trying different things, seeing what works, and yeah, kind of fixing one thing at a time. So glad to have the sub, and I'm trying to get back into streaming a little bit more often, so if you keep an eye out, you'll see me working on this. Okay, yeah, let's get into this. So I'm going to do a little bit of refactoring first to bring these gauges for the like drive and thrusters into their own object. So let's actually just do this here. So interesting. Okay. Yeah. So pretty much all of this stuff we're going to be moving out of here. Just text. Yeah. I think this is all here. And then we're going to clean this stuff up. So, okay, yeah, this is going to want the font. I think we can kind of reference, yeah. This font. And this is going to return this thing. Oops. yeah, in selection, we basically just want to get rid of all these self dots here. And then we're going to pass all of these things. Actually, before we do that, what all do we have here? And that's a gauge. This is good to review what these components do and what they're named, because it's been a while since I've actually, I think I can conditionally add, can I conditionally add stuff? I should be able to. It's been a while since I've implemented this stuff. This was actually quite a long time ago that I implemented some of this basic UI stuff. So I think these are angular velocity. And I honestly don't know if I'm really using these anymore, but yeah. And then we've got these new ones. Oh, and this stuff should go back. Let's see here. What am I using GS text for? Text is, yeah, that's a label for. And we're going to rename these things to something better when we get there. Okay, so now that we've got this, we can get rid of this. Whoops. Actually, let's put these at the bottom. Okay. Okay, so now we just gotta wire all this stuff up. So, oh, and it looks like we ended up with an extra copy somehow. Okay. So, yeah, now we just gotta return this. We'll be renaming some of these to be more sensible names here. And just for now, I'm just going to ignore these. Actually, I take that back. I want to handle this, by the way. And because there's just the okay. And that should take care of that. So now we've just got to rewire up stuff that is using these fields. Okay, so let's see where we have. Oh, so. That. Oh, is there something? Did we miss something here? Oh yeah, GSTextMP. And oh, oh, that's it. Okay. Okay, so now we just have to add a few of these in. Okay, now we're gonna break this stuff into its own update function. So update drive list. And so this is going to take the entity, which is like the entities in this game are spacecraft, right? So it's going to take the entity and these gauges that we're going to update. And I think we can move like all of this in here. Just rename a few things. So is, and we call this player, and yeah, then we can rename this back to ENT, which is what I want. And then basically we're gonna just be replacing these guys. So that's quick. And then let's see here. Where are we updating that text? GS text NP. Yeah. Okay, that is in the right spot. Okay. So basically at this point, things are going to be a little bit cleaner. We will move this build function down to the bottom. And if we've done this right, everything should just work just as it's working now, but now we can kind of focus in on things. Let's see here. Okay, looks like we're missing a couple of texts maybe. Let's see here. I wonder if we goofed up something with the font in the build function. Yeah, that's funny. Okay. None of the text works. That's interesting. Let's just see if something is really crazy is going wrong here. Oh, we're not calling the we're not calling that function. Okay, that's why. So I think it's called something like, let's see First of all, let's move this guy down here. It's update info HUD is what, and that needs to call that. Whew, I thought that was just simply forgot something there, but that seemed like it might have been a really mysterious error, but it's just simply forgot something. Okay. Okay, so we have everything kind of working as before. So let's get these 3 gauges labeled down here, labeled properly, and then we can kind of get into the actual meat of what we're trying to do. Okay. Let's see here. It's going to be something like this. This is awkward, but we'll fix this later. And then just for now, okay, so for now what we're gonna do is we're sort of making an assumption here. This is going to be replaced with better logic that actually looks at some things in the ship components to figure out what force they're putting out, rather than the force rather than the acceleration of the ship, but just for now. We're just going to assume that the drive component is the Y component, and thrusters are X and Z. I'm not sure that's even true now with the way things work, but this is why we're doing this, is so that we can get at this and make sure that it's right. So this is it's always fun to start doing a little bit of vector math, even if it's just as simple as looking at different components. So a drive is just going to be phys.apos.y, and a thrust is going to be phys.apos. Can I say xz? Yes, I can. Perfect. So this is going to be, and I think this guy is that's just a float. And but this guy, is this going to be a vec2? Yeah, it's going to be a vec2. Okay. 2 and vec2. Okay, so this is going to be, oh, let's see here. So drive, and then this is going to be a thrust.length, a thrust.length, and I think this GS text, I think this might only be used inside of where is this even put? Other elements. I guess we'll see. All right, let's take a look at this and see if it looks anything like anything useful here. Yeah, see, where's that? Oh, we gotta flip that around. We gotta make this the apps. Yeah, but where's that GS text NP even being put? I can't remember what that was for. Whew. And my angular acceleration thing is not working. So, and I think that's just a consequence of how the physics, some physics system rewrite stuff that I did. Oh, and I've also got to take this. I've got to take this in the coordinate system of the ship. That's Also why this wasn't working. This isn't doing what I want. So I need to int dot basenp get relative vector. Whoops. Let's see here. So my Jupiter BJY is here. It's good to see you. He says, I'm starting to learn how impressive it is for one to make a game after work. Embedded company I'm in now just drains me devoid of life. Yeah, you know, my day job is super busy too. And I've really been wanting to get back into streaming, and it's like, okay, the only way I can do it is just do it late at night. I used to only stream when I could get started at like 9:45 or so my time, and if it got past that, I just wouldn't do it. I just got to do it late if I'm gonna do it. I would work on this late, but yeah, it's definitely something you've got to do little bits and pieces where you can. That's all right. I'm glad that this isn't my day job. You know, it's nice to have something that you can do and not have to worry about getting done or not have it be a deadline, but just something that you can enjoy, work on little bits and pieces while you, like, when you can. Okay, so pops and okay, let's see if this looks better. Whoops. Oh. Or do I have this backwards? I think it's must be a real number. Okay. I'm not sure what's up with that. I think we're still accumulating fix onto drive. And it's not, let's see here. It's like negative acceleration isn't working. Something's not working here. Well, that works. Maybe I just was slowed down already. Okay, so like if we turn around like this while we're drifting, and then we should see it. Yeah, okay, this is more or less what I expected to see for the way things work now. So Jupiter BJY asks, how's progress been with this game? I see you added moon there. Yeah, the moon's been around for a while. I made that new zooming stars skybox, and then I hadn't gotten the planet skybox working with it. What I've been working on lately is more like better physics stuff, like getting proper impulses and forces and stuff. So I was kind of like trying to do things in a really simple and stupid way before, and I just kind of decided to embrace trying to do things the more complex way. So I've got angular impulses now. Things are very spinny sometimes. Probably you should just blow up if you hit another thing that fast. But it does make combat quite a bit more interesting looking. And I'm working towards adding in, I want to actually try to add in real, like, gravitational forces from planets and some simple orbital mechanics and stuff. So that's kind of why I'm trying to iron some of this stuff out. Is I'm tired of it not being correct enough. I want it to be. I want it to be better. And at the end of the day, I'm kind of thinking that some of that stuff isn't going to matter too much, but, you know, I've got to just do it and see. And this isn't working. Okay, so let us let's see, other than the things that we mentioned, does this look good? I still don't know what that spike there is. That's concerning, but also interesting. The angular impulses are kind of fun. Okay, yeah. So this is a good start. Let me just commit this, and then we'll come back to some stuff here. So okay. Whoops. Man, I'm just scooping everything up here. Okay. Okay. Let's yeah, Jupiter BJY says you spin me right round. Yeah, it's pretty extreme, and I'm actually damping some things there, so there's definitely going to be some fudge, you know, fudging going on to get things to look like I want them to look. But I think instead of kind of coming at the desired effect in terms of like just oversimplification, I think I need to start coming at it from like the perspective of accurate physics first, and then fudging, sort of, rather than fudging in reverse. But we'll see. Okay. So what I want to do now is, now that we've got these gauges, we've got things refactored a little bit, I want to get this working right. So we're gonna look at adding some fields in the game state things for the for the for the things that we want to show, so we're not disassembling things after the fact, but we can look at the forces or accelerations that we're summing up. And yeah, and then we can show the right stuff. So let me just close out of that, and let's see here. This stuff was always just like just like not very nice, and stuff that I didn't like. And it's nice to be getting into it and like feeling like, okay, we're going to get this actually working. We're gonna actually get this working correctly now. So let's actually take a look at the game state stuff, because the other thing that we're thinking ahead of, I'm trying to think ahead about here, is how we're gonna do stuff like power and this is not it. Power and heat for the drives and thruster systems. So actually, it kind of, this is interesting. It looks like we might not actually have objects for those things yet. So that might be actually an interesting thing to do today, is make actual, you can see the physics state got a lot more complicated here. See, we have like these classes that wrap, they kind of have the game states and game specific stuff, and they hold the sort of ship stat stuff inside of it. So yeah, I think we're gonna have to make one of these, make these for the drive and thruster systems. Let's see here. So let's see. Actually, I should be able to see it in here. If I see flight, where do we get flight info? Yeah, okay. So we're getting this stuff from, yeah. But see, we want the actual entity. Yep. So we've got to make drive and thrusters. So this is interesting. So let's just let's dive right in and do this. So yeah, look at this. There currently isn't specific stateful versions of the drive system and thruster system. Yep, there might need to be in the future if we manage them, manage heat for them or something. That's exactly what we're working towards right now. So here we go. On the drive, thrusters. Okay, so Jupiter BJY asked a good question. A bit out of context, I wanted to ask you about that source code folder naming last stream, but YouTube censored my chat of it. Is there a specific rule in naming source directories? So, I'm assuming you mean like source directories for Python code inside the the project. I can show you how I do it. What I do is a little bit unconventional. So, but I use this convention for work as well. So inside my Python project, so here I have modeling projects is the name of this project, and it's called modeling projects because it has a lot of different things in it, not just the game. But I have a uh, 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 like subfolders for different, and with Python, folders are called packages. So I have like sub packages for different projects, and all of the library files are in here. So um, ignore this stuff. This isn't code, but like so jerk is the name of the game engine, or it's like the code name for the game. So everything is in here, and then I'll kind of group stuff in subdirectories as possible. But then what I do is I will put scripts, like executable entry points to things, in a separate directory, and I start grouping these two when things get big enough. So like most of the entry points for the flight simulator are just in scripts right in here. So like I'm always running this like DAO test and DAO ships and stuff. Like this DAO ships run. Yeah, see, we've broken things now so they don't run, but that's okay. This music is super loud in my ears. I've got to turn it down a little bit. But like I'll sort of keep an analogous stuff. So like here under projects, like all of the high detail Blender stuff is a project called HD for high detail. So I'll have like all of the library stuff under here, and then under scripts there's a HD that's like, here's all the entry points. So I can run any of these, I can run, and it'll actually do something. And then these import from projects, right? So like you can see these are going to be importing from projects.hd, like the library stuff. And if you were making a distributable Python package, you would probably want to have all the library stuff in another directory called source. But then the problem with that is that in order to get the things to import right, you have to either install it in place, which is not a huge problem, but it's kind of annoying, or you have to start messing with paths. And if you do it this way, you don't have to install them in place, and you don't have to do anything in your code to mess with paths to get it to work. You just execute everything from the root of the repo, python-m, and then basically just the full path into the directory where it's in, but with dots in between. So does that answer your question? If not, feel free to ask. Feel free to ask more. What I'm doing here right now isn't exactly. I was gonna say it isn't exactly rocket surgery, but it is actually kind of rocket surgery. It's like game rocket surgery. Yeah, and it's a little bit hard to see just because there's some extra clutter here. But like basically, you know, the important thing, like just ignore these models and screenshots and dist and this stuff. This you could all kind of and data, but like there's sort of like two main projects, jerk and projects. Projects has like different sub projects, right? But then all the entry points are in scripts. And if I was going to be, you know, consistent, I could put, and I might do this at some point, I could put jerk under projects. But eventually the game is going to be kind of, I'll probably move it off into its own separate repo. So, and then like so these like modeling Blender, modeling EXP, and art, these are actually packages that I do install with pip. And you can see within that directory there's another folder that's got the same name. Now, you could also nest this inside a source folder if you wanted to separate out like scripts that you weren't going to include in the install, right? So like if say I had some tests or scripts or something with modeling that I didn't want to get installed when I installed it with pip, I could put those in a scripts folder, and then I could put like source modeling or something. But I don't really have that, so I don't do that extra source level of directory structure, because it either means that you have to start doing dumb things with messing with your path, which like everybody does when you look at people's Python code, but you really don't have to do that. So if you start adding that source directory, you either have to start messing with your path, or you have to do local installs, which I don't want to do local install for my main like development area package that has scripts and entry points. Yeah, Jupiter BJY says, since everyone has their own philosophy on structures, it's always nice to watch and learn how others do it. Yeah. It's usually what I find is other people, especially like machine learning people, they would make these Python projects, and right away in every Python script they'd start like, they import sys.path and start manually adding things to the path in the scripts, and it's like, no, don't do that. You don't need to do it. And they start doing relative imports and horrible stuff, and it's like, no, you don't want to do that. Okay, so let's see here. This is going to be where all of our new stuff goes here. So, and actually we'll do these up next to weapon and shield, just because that's what they're going to be similar to. And I don't think do we actually need do we need a distinct name here? I don't think so. Why do I have a name? Why do I have extra names on things? Where did these come from? Yeah, look at that. I'm just copying the info name. How awful. That's why it's good to revisit this stuff, because it's like, why are you doing that? It's okay. I'll stick with the horrible pattern for now. Let's see, do I wanna... Why don't we do this correctly and actually do it, have it be have it produce a force. So, let's see, what do I think yeah, I just call them forces. So, force. And so we're going to have something similar for the thrusters. I think the forces are in newtons, or actually they're probably in kilonewtons, right? Let's see here, because kilogram meters per second. Let's see here. Newton second. A kilogram meter is in newton, right? Kilogram. Let's see here. Newton. Force unit. Let's see. Yeah, that is a kilogram per meter second squared. So yeah, that probably is in newtons. Let's just make this, state this here, just so, and this would be newton meters, right? Because that's, newton meters is torque. Yeah. So, let's see. I always get confused about what, like when you, like with grams versus kilograms, like when is kilogram sort of the base mass unit for other units versus when is it a gram? And here we're going to have a force and angular, what's the term? It's not torque. Jeez. I need to put myself on the spot with this physics stuff more. It really is kind of bad. Oh man. But so help me, that's why we're doing this, is we're going to figure this out. And that is why I'm writing my own physics stuff, and also in this day and age now, why I'm not just having AI do this is kind of the fun part. Yeah, you know, so Jupiter BJY says for torque, I forgot. Yeah, it's just, it's all stuff, it's like it makes sense when you review it, but it's like, it's just a little bit too far removed from everyday experience to be like something that you think about all the time and remember. And I find the whole idea of like angular momentum and moment of inertia and all that stuff kind of confusing. And then there's this whole thing which I've implemented now, but I need to rewrite, where you like do this differential of angular velocity using a quaternion representation and stuff, and it's like, I wish I understood that better, and that's part of why I'm trying to do this, but it's just like, ugh. Okay, but we've got these now. So now we have these extra fields in our entity class. So before we do anything else, we just got to get this wired up, because now we've broken everything. Nothing is going to run anymore. So we gotta fix this, and then once we fix this, then it should be pretty easy to add back in additional fields or whatever that we need. So there's only a few places where we actually build entities in the game. So I think this looks like one where we actually need to do it. And let's see here. I'm just gonna have, let's see, come after devices. So we have thrusters. Actually, this guy, okay, I might be able to just say none here. Ah, okay. Yeah, I've gotta, I can clean this up now. Okay. So yeah, we're gonna do something kind of like this. So entity dot info dot drive system is not none, right? Because this guy should be a optional drive system info, right? Yep. Then entity dot, yeah, okay. Okay, so this is where it goes. This is where it's gonna go. It's gonna go in components. Here's where I actually construct stuff. Let's see, device. Where do I build devices? Components. Here we go. Default device. Okay, I think we can this is just kind of, this is kind of some boilerplate here, but that's okay. And see, some of this is like, some of these have models associated with them, like 3D models and stuff. It won't come into this. So, well, so Jupiter BJY says I can't imagine myself writing my own physics engine. Well, this isn't exactly the physics engine. This is just kind of like how I'm representing things in the game. The physics engine I do have, but like I don't want to show that on stream just because I don't trust myself with it enough to hold it up as an example. And yeah, there's a lot of like converting between reference frames. I do like how I did it though, which is I do the convention where the linear like translational velocity and acceleration is global, but the angular stuff is local, and I think that makes sense. It seems to save conversions, and it seems to match up with how I think about it, because the torque and stuff from the thrusters that affect angular acceleration most of the time, right? Because most of the time you're going to be doing that rather than like hitting stuff, is coming from the local coordinate, like it's coming from the ship. It's axis aligned. So I think that's a sensible way to do it. Okay. And I think, yeah, for now we can just do this. So yeah, here's the horrible Here's the horrible copy here. Info power 0, heat equals 0, force equals pure boilerplate. Absolutely useless. Not useless stuff here, but Jupiter BJY says, yeah, that sounds like a sensible way to represent it. Conventional game engines seem to only expose it globally, so I always have to convert it back to the local frame. Yeah, that's the fun thing about doing it yourself, is like, you know, one way I like to think of programming, and, you know, this is like something that's lost on people who, well, I shouldn't say lost on people. It's lost with the AI, the fact that we have AI coding now, is, you know, back in my day, when you'd write software, what you're doing is kind of like you're building a language, not a programming language, but a domain-specific language out of the functions and components that you are writing. That you're describing how you want to, like, the terminology and the methods that you want to use to solve your problems, and you get to make those decisions so that you are able to solve the problem in the way that you want to solve it, right? There's multiple avenues towards solving that problem, but when you're writing the code yourself, you get to choose, you get to make that decision. Yeah, and Jupiter BJY says, yeah, he has to convert it back to local frames since they need to know which RCS thrusters to fire to kill off angular velocity. Yeah, exactly. And if we get far enough, you'll see some of that in the flight assist code. So I've changed things so that, you know, we're producing torques and stuff. And then the other thing too that you know, that I'm doing now is, like, when it comes to the behavior trees, I was actually based on you know, how a ship would need to turn to face a target, I was trying to affect a certain angular acceleration, and now I'm trying to affect a certain angular velocity. So there's kind of like a, I think, like what you're describing, where we're looking at, okay, what's my angular velocity now? How am I trying to increase that or decrease that to some target, right? So there's kind of like, there's like the actual, like, forces and torques that are creating acceleration, and then there's the flight control system that's saying, okay, given where I want to be pointing or where I want to be, how do I change the target velocity or the target angular velocity, right? And all of that's kind of unified now, so it makes me feel, that was the other thing, is it makes me feel better about digging into the physics now that there's sort of like a layer, a logical layer in between, like, the game logic and flight control logic and the actual physics engine, right? It's not, they're not so tightly linked. Okay. Now, there's a couple other spots where we construct an entity, and those are going to be easier because we know these things are just going to be none. So this is asteroid. And this is a nav point. And that was the debris chunk, I think. Let's see here. That last one. Yeah, debris chunk. Yeah. So Jupyter BJY says exactly. I have a 5,000 line helper functions package that does calculate such as heading and position acceleration with simple P control. Yeah, so I've got PID controllers, and I started setting up some stuff to tune them too. And that was the other thing, is I was doing like a PID control on target angular acceleration, which didn't really make sense. Or it was like one level too low level that I was doing the PID control on. I still would like to find a more principled way to come up with the PID tuning. That's the thing that bothers me about PID controllers. It's like I'm not familiar enough with the math of it to be able to say like, oh, here's what the closed form like there should be like some closed form or some way that I could tune those things. But yeah. Yeah, Jupyter BJY says since in the end it should generate generally 6-axis control input. Yeah, and that's kind of what I came up with too. I forget if it's exactly like that, but it's pretty similar. The AI PID controllers might be operating at a little bit lower level than human input, but they work pretty well. Like you know, they'll track angular heading and stuff, and it's cool to see. It's cool to see when it works. Okay, so I would expect this to run now. Yep. Okay. And we're not here. So like I can I mean, that's a PID controller there that's doing that face. Like if I translate, it's remaining faced. It's a little bit of a bounce to it, but that's the other thing that kind of scares me is like all these ships have different properties, and how do I tune PIDs for them? But we'll figure it out. Okay, so now that we have these devices, we can put information into these force and torque things and get it back out for those gauges. So let's work on doing that. Okay, let's just close all this. And actually, I'm just gonna commit this. There we go on. Okay. So let's take a look at the autopilot. And this, I mean, so this logic definitely needs to be fixed. It's not what I want. But we're gonna just start by getting what's happening right now in there, which is there's a certain force and there's some certain forces that are being accumulated that are being described a certain way, and let's just attribute those to the components that they're supposed to be coming from, and then go from there. So let's see here. Yeah, I feel your pain, Jupiter BJY, about the YouTube videos. I've left a trail of some, stuff that seemed really cool at the time, but I've got better I've got better things now for sure. Let's see here. See, this is kind of funny. But okay, let's just actually spend a little bit of time reading this. So what is actually going on here? So this I'm describing as correction, but really this is going to be the main sort of burn. Yeah, I feel you. Wanting to go to work on projects instead of your job. I sympathize with that. Although I do like having this just be a project and not something that I have to do for a living. So apply burn, I think, is, yeah. So this is going to be the actual main drive. Or actually, A pause plus A adjust. That is exactly what the two components are that I need. I think. Okay, let's see here. Oh no, unfortunately not. see here. Okay. This is, yeah. Okay. So it is going to be this. So, and we're going to assume that we have these things right now, but actually I can just check. So if ship dot drive is not none, ship drive dot equals this guy a adjust times and then if ship dot thrusters is not none, and ship drive dot or ship dot thrusters force equals a adjust times ship is. Okay, now I'm fairly confident here that this is basically what is happening right now. Now, whether this is actually what I want, I'm not sure. I think it is, because I'm saying basically the thrusters are like just completely separate from, like the main drives are just pointing along the y-axis, right? And then the thrusters are like whatever thing is not that. Like we don't, like I don't have any thrusters that also are pointing along the main axis. Okay, now let's also put the torque in the thrusters. So if ship dot thrusters is none, ship dot thrusters dot torque equals torque. And there's that moment of inertia calculation that we're going to have to undo here in just a second, but whatever. We'll at least get as far tonight, I think, as sort of showing clearly in these gauges what is currently going on. Which, if nothing else, is like I mean, it works. It makes some compelling. Some compelling visuals. Okay. First of all, let's see if this causes any problems. Okay, this still runs, so that's good. Okay, so now we can go back into the HUD and use those for our gauges. Yeah, I mean, I think I have enough sense to know like when stuff looks nice and when it doesn't. So it's like I'm not completely off the mark. Um, something that's kind of fun to think about too is when you have these kind of goofy things like how fast it's spinning. It's like it's good to think about. Okay, like that's probably what would happen if you crashed a ship into another ship that fast. So I'm not picturing that happening. So why not? And then it's like, can I come up with kind of a cool explanation for why the sort of magic drives in my universe would prevent that from happening without having super powerful thrusters or something? You know, these things like when you discover unpleasant things about how physics actually works, that's an opportunity to do some interesting world building or solve problems. So okay. Okay, so yeah, now we can undo this nice little logic that we did before and get this stuff directly from the components. So this is going to be, these will actually just all be floats now. So this will be int dot drive dot force times stop length divided by int dot phys dot mass. Dot thrusters. And we got to revisit this logic here, but again, I think we're closer to what we want. And then this, okay, let's just test these two because that last one's going to be a little bit annoying. I'm gonna embarrass myself here on stream with the, oh yeah, oh okay, but yeah, we need to clear the thing that we're not doing is that we need to clear those. We need to clear those when we run the flight assist, or actually probably outside of it. So let's see, it's going to be at like the beginning of the game loop. So this seems like a good spot to do this here. Clear physics accelerations. Yeah, I think it's fun leaving those notes. I think the more I write code, the more it's like you got to just leave a lot of notes for yourself, and it's kind of fun to be humorous about it. Okay, now that's weird. Why is it? Okay, that's strange. It shouldn't be disappearing like that. That is weird. It's weird. It's like it's getting cleared out while I'm holding the key down. But like once I release the... That's odd. Is there something else that is... Something else that is filling or would be setting that? Resist torque. Oh, okay, here, it's this. It's this case. So this is... I don't think this branch is ever really used. Well, it is dummy. Let's see here. Here we're using, yeah, a rec max. So definitely want to do. But this is strange. No, maybe that's not it. Interesting. So there's, see, the thing is though, there's, so I've got this. We can look at the forces, like burn adjust, right? Like when I'm, what is going on here? See, why is that flickering like that? Oh, is it just... Oh, it's just because I'm not... They're like super... Are those like... Are those like really tiny forces or what? See... Oh, wait a second. Where is burn? There it is. Okay. How did I miss this? Oh, look at that. That's funny. So there's like a totally separate spot here where I'm actually just straight up applying burn. So okay. I guess that's fine. Oh yeah, okay, I know why I'm doing this. This is for the analog control over the burn factor, so that's why I'm doing it in handle controls. Force equals this. And if player dot drive is not none. Yeah, and then this increments the target. Okay, so then player dot drive dot force. All right. Okay, we've got something negative. Negative numbers aren't showing. Oh, okay. Let's see here. I'm just gonna try to fix that quick. What's it? Cluster stop length. That's odd. Oh, there's another source. That's why it's probably called thrust or something. Dot forces dot append. And adjust. Strafe. All right. Force. What's this? Force. Rust. Let's see if. And I think that tiny little bit of main drive acceleration is, oh, that's weird. Like you can actually see it bounce a little bit. I'm not sure what's causing that. If it's just like, just little tiny. Oh, yeah, it's probably just how I'm. If I'm not, yeah, if I'm not releasing things at exactly the same time. Now it's still odd to me that that flickers like that. So maybe that might be something to look into. Like, I'm curious. Curious what is going on there. Like it looks very like when you look at the velocity, it looks very constant how the velocity increases, but it's interesting that that's flickering. It's good to do stuff like this because we could be kind of sniffing out some little bugs in how things are implemented, for sure. But in general, this looks right. Now, our angular acceleration is not working quite yet. So let's try to get that done and then we'll call it a night. So, yeah, so for our angular acceleration, basically, instead of doing what we're doing right now, we've got to reverse that, or convert torque to angular acceleration. So I apologize for some potentially bad bad physics code that you might see here, but we'll see. Yeah, Jupiter BJY is something with floating point area. Yeah, it's definitely logic that I need to revisit. Probably just some weird little thresholding issue or something. Yeah, I think that's what you're describing. I think is exactly what's going on. And you couldn't see it before because it's like happening at a high enough frequency that the velocity just looks like it's increasing smoothly. But okay, so when we calculate torque, we're x-forming I body from this desired AHPR. So we basically just got to go backwards. But actually, this is, yeah, we still have to transform by this because that's going to be a scaling. We don't care about the actual individual components of this. But let's see here. It's going to look like this because we do this actually let's take a look at our new one. So this is just happening this is that quaternion nonsense here. I think what we can do, let's not dwell on that. let's use this guy. And we can assume that our main chip has got that information. So let's see here. It's going to be this guy that we want. So I'm doing this extra radians to degrees conversion just to maintain some backward compatibility with something. So so HPR is going to be put this guy up here. Because we're transforming torque backwards and then converting. Yeah. Okay. And then we've got to turn this whole thing into get the length. Oh, the other thing, Jupiter BJY, that I did that you might be interested in is that I am storing the positions of everything with double precision coordinates. So that's going to enable like some planetary distances and gravitational forces and stuff like that. So I already have a system where I'm storing the true position of things separately from how it's being rendered. So you can have a floating origin, so you don't have like janky you know, vertex bouncing around as you get farther away from an origin. But that's been updated to all be double precision now. So we can just model real distances. Okay, now we'll see. If we got this anywhere near correct, it should be roughly within the... Yeah. Yep, look at that. It's... Yeah, look at that. It's spot on. Okay, so whatever I'm doing there is like is basically exactly what I want. All right, well, we definitely have some things to look into in terms of like why this guy is flashing. But I think we've sort of modeled now with components some things that were sort of happening before, just in how we're accumulating things. We can visualize what's going on a lot better, and we're in a good place to start rewriting and refactoring and fixing these things to deal with new forces, new situations. Like I said, I want to try to start getting some more correct orbital mechanics and planetary forces and stuff in here. So yeah, and let's see if we look at forces. Yeah, there's that burn adjust, right? And then when we're doing this, it's the burn. Oh, it's the burn adjust that's flickering. So the burn is staying constant. It's the burn adjust that's flickering. I bet I know what's going on. I bet it's just certain directions. That's not my EPS is probably too big. Let me just see this. Yeah. It's not happening in the burn direction. Yeah. So Jupiter BJY says, yeah, maybe having a slight margin in target velocity when target velocity is not zero would be a way to test if it's actually the cause. Should replace all my calculations with double precision. I totally forgot about it. Thanks for the reminder. Yeah, happy to help. So here there isn't really PID stuff. It's this is just the flight control system. I'm still not sure why it's flickering off like that. That's strange. But let's see. What's my forces list? It's like it's turning on the burn adjust and straight up the opposite. Oh yeah, see, look, it's just super duper small. Strange. All right, well that's definitely something to investigate, but all right. Well, I think we made some good progress for the night. We're getting deeper into what I hope to get into, which is kind of laying bare some things and debugging some old issues and trying to get systems working better and not just kind of a patched simplest thing that you could do, but behaving more like a real system. So thanks again everybody for hanging out. It was a good time. I always like chatting with people, seeing what people are doing on their projects. I hope if you watch this that you're encouraged to work on a project of your own. I'd love to hear about it in the comments or chat another time. And if you're interested in this stuff, I mean, definitely subscribe. I'm trying to get back into streaming more often, and hope to be doing that. So have a good night though. Thanks for coming again.